in this video we are going to talk about combined gas laws. Now, we have already talked about Shell's law, we have talked about Boyle's law, and we have talked about Graham's law. And you can check the videos below for you to be able to understand if you have a question under those gas laws. You can also leave a comment if you have a question, and then I'll get back to you. Now, don't forget to like, share, and subscribe as well. So let us start. Now, before we proceed to doing the questions, we're going to do 3 questions. Let us just remind ourselves the most important things under combined gas laws. The first thing is, this is a combined meaning we have 2 gas laws which have been joined together for you to form now this combined gas law. Which are these 2 gas laws? It is Boyle's law and Charles' law. Okay, so combine these 2 laws, you get what? You get your combined gas law, which is going to be PV over T, like that. Okay, so this is where we get our combined gas law. So the formula of our combined gas law is, we say P1 V1 over T1 is equal to P2 V2 over T2. So for combined gas law, what is going to guide you is you're going to have the variables that we talked about, temperature, pressure, and volume changing. Okay, so we're going to have the initial, the P1, V1, T1 being completely different from P1, from P2, V2, and T2, unlike in other gas laws. Now, let us work out the first question. You're told a fixed mass of a gas occupies what? 200 centimeters cubic. So we are going to label here, that is V1 at a temperature of 23 degrees Celsius. That is our T1, and a pressure of 740 mmHg. We say it's what? Yeah, millimeters of mercury. So this is our P1. Calculate the volume. So we're being told to work out V2 at negative 25 degrees Celsius, which is our T2, and 780 millimeters of mercury, which is our P2. So that is how you're supposed to be doing, so that it can be easy for you to do it. Okay, so the volume, the pressure, so we are asked to work out volume. So we say the formula is P1 V1 over T1 is equals to P2 V2 over T2. Now let us work out the equation. So our P1 is going to be 740 millimeters of mercury. So the question is going, so this is how we're going to work it out. It's going to be 750, okay, P1, you multiply by your V1, which is 200, over T1, which is 740, to give you P2, which is 780. You multiply by your V2, which is what we do not have, over T2, which is negative 25 degrees Celsius. Okay, now, okay, let us put it here, 25, right? Our T1 was what? What was our T1? Our T1 was 23 degrees Celsius. Our T1 was 23 degrees Celsius. Now, we have to convert our temperatures, which are in degrees Celsius, okay, to what? To Kelvins, or to Kelvin. So how do you do that? We said from degrees Celsius to Kelvin, you do what? You add 273. So it's going to be your 23 plus 273, okay? When you add, you get 2, this is 23, right? Yeah, plus 273, this is 6, this is 9. So it's going to be 290 what? 296. When you add negative 25 plus 273, you're going to get, your answer is 248. So this is 248 what? Kelvins. So we are going to replace and rewrite the whole equation now in a manner that we can be able to now start working it out. So it's going to be your P1 V1 over T1, which is 296. After you have converted it, you have to convert your degrees to Kelvin before we proceed. So over 248 Kelvins, okay? over 248. So let us work out our V2. So our V2 is going to be what? So you're going to cross multiply to make your V2 the subject of the formula. Now this is going to give us what? It is going to be 780. Let us just write 780, you multiply by V2. So it is 780 V2 times 296. I hope you can see here. Times 296, okay, is equal to 750. 750. Let me come on this side to this side. 750 times 200, okay, times 248. When you work this out, you're going to get 230,880. V2 is equal to, it's equal to 3,600,000 and you're going to get 3,670,400. Okay, so you make your V2 the subject of your formula, which is going to be, you divide by 230 there, you divide by that, and you divide it by that as well. That and that cancels out, and you finally get your V2 as 158.97 centimeters what? Cubic. Now let us go to the second question. So you're told, we have written the formula here because these questions are all under combined gas laws. So you have a gas has a volume of 0.2. So this is our volume 1, okay, at standard temperature and pressure. Okay, calculate the volume of the gas. Calculate the volume the gas would occupy at a pressure of 1.01325 times 10 raised to power 5 pascals and 125 centimeters cubic. Now, you see this word? At standard temperature and pressure. What does that mean? At standard temperature and pressure, the pressure is going to be 1 atmosphere, which is equivalent to 1.01325 times 10 raised to power 5 pascals. So this is the same as this is, we've said at standard temperature and pressure, the pressure is 1 atmospheres, which we said is the same as 1.01325 times 10 raised to power 5 what? Pascals. And what is our temperature? Our temperature is going to be 270 what? 273 kelvins. So if you see at STP, it shouldn't worry you. You just need to know at STP, your pressure is 1 atmosphere, which is 1.01325 times 10 raised to power 5, and temperature is 273. Okay, so these are our, so we already have our V1. So our V1 is 0.2. Our T1 is 273. Our P1, this is our P1. Okay, so do we have our P2? Yeah, our P2 we have already been given. It is the same. 1.01325 times 10 raised to power 5. T2 is 127 degrees Celsius. Okay. And do we have our V2? No, we do not have our V2. That is what we're being told to do. To work it out. Calculate the what? Calculate the volume. And you know this is V2. Now let us equate this. So it is going to be, our equation is going to be P1. So it is going to be 1.01325 times 10 raised to power 5. Okay. You multiply by your V1 times 0.2 over your T1 over 273. Okay, 273 Kelvin is equal to your P2. The P2 is 1.0. Let me move to this side. Our P2 is 1.01325 times 10 raised to power 5. You multiply by your V2, which is what we don't have, so V2 over your T2. Now our T2 is what? 127 degrees what? Celsius. So we have to convert our degrees Celsius to Kelvin. And we said for you to convert degrees Celsius to Kelvin, what do? You add 273. So it's going to be your 273, you add your 127, and you're going to get your 400. So over 400. Now, after you have done that, what do you do next? You cross multiply in order for you to make your V2 the subject of the formula. So when you cross multiply, so when you work it out in your calculator, because you're going to use a calculator in this case, you're going to get your answer as 68 is equals to 253.3 V2. Okay, so to make V2 the subject of the formula, you divide by 253.3 to 53.3, and your V2, your volume 2 is going to be 0.27. Then let us put the units. So that is how you were supposed to work the second question. The third and the last question, you're told a gas occupies 100 centimeters cubic. So we have our volume, this is V1, at 0 degrees, that is our temperature, and 1 atmosphere, we have our P1, T1, V1. Okay, calculate the T2 at which the V2 is doubled. It is what? It is doubled, and the pressure is halved. So our P1 is going to be, our P1 is 0, our P1 is 1 atmospheres. Okay, so it is 1. You multiply by your V2. Your V2 is 100. You divide it by T1. Our T1 is, so 0 degrees Celsius is 273 kelvins. Because we said you convert degrees to Kelvin, and degrees to Kelvin is what? You add 273. So if you add 0 to 273, you get what? 273. Now, is equal to our P2. We have been told that our P2 has been what? Is halved. So the P2, we are going to do P1, you divide by 2. The half of 1 is 0.5. So this is our what? Our P2. So times 0.5, that is P2. Okay, you multiply by our volume, which has been doubled. So our volume is 100. So 100 you double, you multiply by 2, you get 200. Okay, so we get 200 over T2, which is what we're looking for. Now, what do? We are going to also do what? We are going to cross multiply. And once you have cross multiplied, you are going to make T the subject of your formula is equal to 27,300 over 100, because this is going to be, okay, this 100 over 100, that and that cancels out, and your T2 is going to be 273 kelvins or Kelvin. So that is how you're supposed to answer questions under combined gas law.